That is the cache. Similar one is the buffer. Buffer is the same as the cache. What is the difference? Buffer and cache. Short term?
Buffer is much more short term.
Short term. Cache is also the temporary. And what is the difference between the buffers?
In a queue, if you want things to be done, but right now resources are not available, then you can form a queue, so that's when you store things.
Quite similar.
Buffer is more constant.
Constant. It's when do you need a buffer? Like think about when you drive a highway. Okay, when you exit, usually there is the beginning of the ramp. There is a buffer in case of you hit. So if there is a speed gap, so this is a fast, wide bandwidth. This is a narrow bandwidth. Okay, so if you feed on this way, okay, you cannot fully utilize this one. So it will be in other cases slow when you watch the video stream. Instead, if you keep the buffer in between, so first time is delayed, okay, but you keep the data on the buffer, then you can stream. Then you may not realize such a different speed gap. So buffer is used for to bridge the gap, speed gap, okay, the bandwidth gap. So that is slightly different from the cache. Cache is the area for the frequent access data to speed up for I/O, and the buffer is to bridge the speed gap between the medium. So this is a storage device hierarchy that we will discuss the more details in the I/O management. Okay. Let's talk about the caching and most of the things this is an overview of the computer architecture. So direct memory access structure means, so anyway, to read this is an example, the CPU request to read the data to the disk controller, read the data and the interrupt and return to where? Actually, if you follow the computer architecture, it's the instruction by instruction you need to get controlled by the CPU. It needs a lot of the overhead, so context switch or something other instead. So it's just to return the data. So why don't we directly return all the data to the specific area of the memory? Then later, the CPU, if the CPU knows the address, just read the data. So that is the idea of the direct memory access. So direct memory access is bypassing the CPU control. Everything should be controlled by the CPU. So like the interrupt. Interrupt means what? Interrupt the CPU. When we interrupt, it's interrupt the CPU time. And then we can do the next thing. So this is the main component of the computer architecture. So everything is controlled by the CPU. So if when we read the data, it's also controlled by the CPU. It needs the CPU time. So instead, when we return when we read the data is the batch of the data. So we can directly, bypassing the CPU, just directly transfer the data. Then it's called the directory memory access. To do that, we need the specific hardware. Okay, so that is to call the DMA, the controller. So using that DMA, so we can directly copy the data without removing such an overhead. So as we talked, all the operation in the operating system is interrupt based. So request and send the data and using the interrupt and the same thing. So we can copy the data. So instead of just the copy to the memory. That's the idea of the DMA. We will discuss about the more details in the I/O management of this one. Okay. But computer system nowadays is not only the single processor, it's a the processor. What's the difference between the multi-core and the multiprocessor? What is a multi-core?
Single processor with multiple cores.
Single.
Processor with multiple cores.
So one
Physical processor.
physical chip. Okay. So one processor has the one chip, and inside there are multi-core. Each core can process one thread of the instruction. One thread of the instruction. What is the benefit of the multi-core and multiprocessor? Comparing to the multiprocessor, what is the benefit of the multi-core? Both of them can process multi-thread.
There is no overhead of managing processes.
That can reduce what? So main thing is energy. You can reduce a lot of power. If you have the single chip, so the main struggle of the CPU is actually the power. So is there anyone who invests the Bitcoin? It's a hard issue, especially in my hometown, Korea. It's, the Bitcoin is really, so government would like to prevent the trading of the Bitcoin, then all the investor and the user and angry, so the government cannot do this one. So for me, I have seen the Bitcoin several years, so personally, because of the blockchain idea. So, but the Bitcoin, I still personally believe all the capital should be based on the human labor. That's my thinking. So, but that's the reason even I do not invest the money a lot. Personally, I don't do the invest the money to the stock market. So, but no way to avoid the stock market, like the pension, and we need to do that. But the Bitcoin itself right now, I agree the idea of the Bitcoin, that is the cyber currency, because right now, for example, the U.S. government, the core currency is right now is the U.S. dollar. That's true, which means the U.S. government will not be collapsed or bankrupt forever. If we need the money, then just print out the money forever. So because that is, which means the government, each government own and support. Because of that is the currency. Each country can manage their own currency, but because of that, that is the too much power to the government. But if cyber money, like the Bitcoin, is the generally used, then nobody can control. There's no dominant power of it. There might be those who create the Bitcoin. I heard that some of the inventor owned a lot of the portion of the Bitcoin. But in general, the idea of such a cyber currency will reduce a lot of overhead and make it simpler, and it's more transparent. But the problem right now is just without the reflection of the human effort. So that's not used for the currency right now. It's just for the investing purpose. But when we invest, there might be something, the fundamental reason. Okay, so like the resource, natural resource. So there is a value. So we can invest, like the option or the hedging. So we can do that. But the Bitcoin itself, there's no the rational yet. It's just the gambling, I believe. So, but anyway, why do I mention this one, the Bitcoin?
Difference between multiprocessor and multicore energy efficiency.
Oh, energy, you're right. So, but what is the idea of the Bitcoin? So there is some limited number of coins that can be generated by the decode. Okay, then you can mine while you are running the program, you can mine. At that time, what is the biggest problem? It's just the computation, which means use the CPU processing. It's not read and write. It's just the computation, which means the processor running 100% almost, which means it create power consumption. So power is the issue. So somebody if versus the energy bill. So which one is bigger? So whether getting the Bitcoin or this one. So but still this one is beneficial, but the power is the most struggling part when you mine the Bitcoin. So because of that, the single chip actually saved a lot of energy. So still the main problem of the CPU, the chip, is the power, how to reduce the power. If you see most of the problem happen in the cell phone and the laptop is related to the power, the energy consumption. So that is a multi-core system, and the multiprocessor. Mostly in this class we are not going to talk about the multiprocessor cases. Instead, we will learn the single core, the single processor case. Then it's not easy to extend to the multi-core, the multiprocessor case. So if we offer the advanced operating system, we can talk about the distributed operating system or the multi-core multiprocessor system. But unfortunately, we do not have. From time to time, I will introduce very brief the types of such a multi-core and multiprocessor system, like the tightly coupled system, loosely coupled system, parallel system, and the cluster system, and so on. So this is the CPU processor has their own register and the cache. So this is also the problem when you have the multiple processor, how to manage the different caches. This will be overhead. So there are two types of the multiprocessor. One is logically it's considered the one CPU. It's an SMP machine, the symmetric multiple processor. The SMP considers a number of processors as logically just one. And the operating system will be in charge of the distribute the job and assign the job, allocate the CPU. And the program side, the user side, is just considered as one CPU. On the other hand, MPP, the processor, massive MPP, massive processing unit, and for anyway, so MPP, massive something. So MPP is a shared nothing, so which means the user should be CPU and its own memory, and the operating system is distributed. So user should consider such the parallel processing in their programming level. So, but nowadays most of the operating system is the SMP machine, which means the operating system is in charge of that. Otherwise, if you want to do to get the multiple processor and multi-core, so you can do the multi-core and the multi-processor programming separately. At the time, you need to use a different library. Most important part is you need to make the group of function that can be run the specific processor. So this is the idea of the dual multi-core. The design is on one chip. Okay. Cluster system is the number of the cluster system is the number of the computer system. Nowadays, the clustering, the approach is used a lot, like and the CPU memory, and sometimes local, the local disk, but centralized the storage. And physically they are distributed, and for example, we can use the distributed operating system for the cluster system. Okay, so when you are using for example, one of the example of this one is HDFS, Hadoop Distributed File System, which is one of the big data solution. So this one, if you submit the job, then it's automatically distributed and balanced. and coordinate the parallel processing to get the benefit of the number of node, which is called the cluster system. Nowadays, the cluster system is more popular than the MPP, the architecture. Okay. Another thing is I think this is undergraduate level, the question, what is the multiprogramming and what is the time sharing? Multiprogramming is the degree of the programming, how many jobs processors are running simultaneously. That is a multiprogramming. Nowadays, most of the operating system is a multiprogramming. To implement such a multiprogramming, we can do the time sharing. Because we cannot separate the CPU time, instead we can share the CPU time by slicing, which is called the multitasking. So we will learn the such a time sharing approach based on the CPU scheduling. So and also the virtual memory. So we will learn in chapter 5 the CPU scheduling. Another important characteristic of the operating system nowadays is the dual mode. Dual mode means so, for example, this program, I'd like to read the data from the file. So then, what you can do is the actually operating system. Operating system provide the number of API, the system, the function, which is called the system call, to access to everything regarding to the handle and the access coordinate or to the hardware. Because it's not easy for user to implement all low-level programming to implement the application. Instead, the operating system provides, for example, to read the data, why don't you use the read the file, the function. This is already implemented by the operating system. So you are able to use this one. Also, for example, I'd like to create a file. How do I create the file? It's already provided as a function. That is, for example, for or AXAC. Such a number of, usually it's 150 to 250, depending on the operating system. Like the Linux will provide around 200 system library. Using this system library, you can do everything. Like I never used such a system library in my application. Yes, you probably you don't realize that because your programming API used this. So it's high, the abstract, this one, and this is called the system programming. It's like the little bit low-level programming, mostly C or the C++ programming. But if you are using Java or the Python, I never use. Yes. So instead, Java and the Python per programming use this system library. Okay. Then I'd like to use this system library, read the file directly, but the operating system does not allow to call this system library directly by the user. The reason is that if you allow the operating system allow each user to run this library, which means you need to have all the permission to the hardware. Okay, then it will be huge security work and it will be conflict the situation. Instead, the user actually request, I'd like to read the file, okay? Just request this function. Then there is a kernel. Kernel is the the kernel process and the system process when we start up the operating system. The process is in charge of to execute the read the function. Then just return the output only to the user. So there are two modes. Whenever we run any application program, it's always the two modes. One is the user mode and another one is kernel mode. Especially kernel mode, when we run any system library that access the resource or the coordinate any system library, it will be executed by the kernel. Then between them, just request and return send the parameter value. So like the which file and the read write permission, and the output will be returned to the user. Okay. So there are always the two modes. It can be represented by the mode bit. Each process has the mode bit. So it's 0 is the user mode and 1 is the kernel mode. So it's take turn between the user mode and kernel mode. So because of this one, sometimes if you see the let's update. If you see this is the CentOS, so virtual machine. So this is a command to see the overall this virtual machine status, so like the process state, the memory. Later I will explain the more detail. But when you see the CPU usually when you see the CPU time, there are two, actually more than two, but basically two. User time, US, and the system time. User time indicate any operation on the user mode. That exclude such a system library. Just the user code means the for, while loop, for loop, and integer, assignment, and so on. But if you call the system library, that will be performed by the kernel. That is the system mode. So you can see that right now this system is not doing anything. But if your system is busy, you can see the different number. So currently the 99, 100% are idle. So and the last one is the wait. Wait means it's the I/O wait. During the I/O, the CPU cannot do anything. I already explained it here. The CPU can do the computation, operate the processing, the instruction. But if we request to read the data, there's nothing the CPU can do. It's a wait. So it's an I/O wait. So you can see the two main, the CPU time, the user time, and the system time. So this is one of the indicators, whether my system is running correctly. If the kernel, the user use a lot of CPU time, user module, a lot of CPU time, which means no time for the kernel, which means it will be slow. So you need to balance. It's usually 1 to 2 or 1 to 3, the ratio. So which means kernel should get the CPU resource, this one. So for example, if you have the infinity loop on the program, like the while loop, without computation, just while loop, the user mode will be 100 easily. Then the system cannot get the CPU time to process the system library, kernel mode. So this is called the dual mode. The operating system actually basically use the dual mode. One is private to protect the system. Okay. So the main reason is to protect the system. So it used the dual mode. So one of the indicator to see how it is working. So you can check the performance monitoring tool. So you can see the CPU time. Or another command is you can use the top command. So you can see the CPU time, the system, CPU user, and the system time. over here, such a the ratio. So that is the user mode and the kernel mode. Any questions so far? The most of the thing we will discuss in the from the chapter 3. So this is kind of overview of the overall computer architecture and the operating system. So the system core, we will see the details about the system core the next class. So that system core is kind of a system API. If you are taking the Unix program offered by Professor Arjuni, so you will learn more about how to use the system library, system core. So that is also high pay, the salary job. So for the Unix program or the low level program. So there are a lot of the developers who can use the high level programming like the .NET or the Java and everything, but nowadays it's very hard to find someone who has experience on the system library or the low level program, because definitely you need to understand the hardware and the operating system. And the good news is that such a system programming is not very the long line of the code. So mostly it's the 10 to 20. Because it's used for the system, the purpose. It should be very simple, but it's very hard to find the experienced person. Okay. We will spend, I think, the full 5 weeks regarding to the process management. So I'm not going to the overview of this one. I already explained many of the most of the thing in our previous introduction. So this is one command when I teach the operating system about the common mistake from the student. What is a process, by the way? Process is the data structure. Really, it's a fully 100% data structure. It's really the very detailed, defined data structure. For what? In the memory. If that is not matched by the CPU, CPU cannot understand where is the next program counter instruction, where is the array data, which one is the garbage, which one is the global variable. It's clearly defined by what? First, the processor. CPU, the manufacturer, like the Intel, AMD, they clearly define this is a 32-bit processor, it used this instruction. Then, by following this one, your compiler should understand. Okay? Both your programming, and also the hardware, your CPU. Then the process will be designed, structured by your CPU, so you are the compiler. So if you have a chance, this is one of the regular things in our curriculum. There is no compiler class. So, but the compiler is one of really the most my favorite class. You can understand the programming, you can understand the hardware, you can understand the data structure. All of this in the compiler class. So then, if you have a chance to learn the compiler, you need to clearly design what is the initial size of your process. Think about what is the main job of the compiler. Is to convert the high-level language to the assembly. At that time, the programming code will be loaded into the memory when we execute. Then the structure will be determined by the compiler. That is the reason if you have the same code but the different CPU, you need to compile again. Okay? Why? Because their process data structure are different. You need to use different compiler. Okay? Then this is the process structure. It's one of the example. So it's a very general the data structure like the your programming code and the global variable located here the like the address this is a 0 and this is for example the 2k and 2k to the 3k is a global variable and this is a heap dynamic allocator memory and this is a temporary space and so on. This should be defined in your compiler. And we will see details about such a process data structure in chapter 3. Okay? Then finally we can create such a process. Then how to create a process. As I briefly introduced, process will be created by another process, always. So it's called the parent process. Actually it's very simple. Just copy. When you double click or when you touch, when you run the program, what happens? Just copy the current processor. What is the current processor? This time my current process is the desktop. Desktop is the current process. If you are using the shell, like this one, my current process is the bash shell. Then run the PS command. PS command means is to create a new process. How to create a new process? Just copy. Really just copy in the memory. Okay? Then load the new programming code like the PS. There might be the PS program code which was compiled already. Then it will be copied to the clone, the process. Then will be new process. So this is how that is the reason. That is the reason. You can see the process ID is 0 and the 1, 2, 3. Their parent process ID is 0. So 0 created this one, and 12. The 1 created 283, 4, and 160, and 227 create the 229. 227 is not here. So that is the kind of tree structure. The process has the tree structure eventually. Okay? For the memory management, so we will discuss about the memory management. The main idea of the memory management, since we have the really limited memory resource, we need to anyway the in and out and replace. So the memory replacement will be the main job of that. We will talk about that later. And the storage management. And we will see very briefly about the protection and the security issue. That is a separate chapter, but I don't think we have enough time. But we will see very briefly about the security that is based on the group and the user ID later. Current data structure will be and okay, so the last part by explain the computing environment I'd like to